How you doing? Today we're going to be exploring some Border Gateway Protocol BGP as a comprehensive EIGRP, OSPF, and BGP. We're going to be redistributing these three routing protocols and see how it can work in a network topology. So this is the topology over here we're going to be working with, and the platform that I'm going to be using for this configuration is Cisco Modeling Labs virtual labs from Cisco. So I have already installed everything. I'm using VMware Fusion. So I'm gonna start the CML over here, and it's gonna ask for your Mac password, the user, and the password. And as you can see over here, it will show you an IP address that you should be using to log into the modeling lab. So I'm gonna minimize this, and it's HTTPS 192.168.1.48. You gotta enter your username and the password. And I have the lab already assembled in here. So what I'm gonna do, I'm gonna go ahead and start the lab. So we gotta keep in mind over here, since this is a modern lab, so we are not gonna find any serial interfaces on the routers. In this lab, this is pretty old, I would say lab, but it will do the job. So on this topology to the right, we will see that we have serials that is used to connect these routers. But on this, or in this topology over here in the virtual labs, I'm going to be using the gigabit Ethernet interfaces. So here's the deal. Horizontally, between the routers, I'm going to be using the gigabit Ethernet I0/0, and vertically I'm going to be using the GI0/1. So GI00, GI00, over here we got the GI0/1, GI0/1, and on this interface between these two routers horizontally I'm going to be using the GI00. And as you can see, they have simulated that there are local area networks that are connected to each and every router, so the interface I'm going to be using is the GI0/3. So now the routers are booting up. I'm gonna type in no. Start the second one, press enter. I'm gonna type in no on the keyboard. So we're gonna be doing our own configuration. I don't remember I've ever done an automatic configuration. So the loading for these routers, it should take about 3 to 4 minutes. So in the meantime, let's take a look at the tasks that we need to accomplish with this lab. So I just put it as a comprehensive EIGRP, OSPF, and BGP. The first and easiest part is to configure host names and IP addresses on all routers. Then we're going to be configuring EIGRP using Autonomous System 254 only for the R1, R2, R3 links. So we got to configure EIGRP on these links over here. Then do not enable EIGRP for any other subnets. Verify your configuration. Third task, configure BGP and Autonomous System 254 as per the figure. So as you can see that we have added the local area networks to the BGP, but we're going to be redistributing these using route maps into BGP. Use physical interfaces for peering, so we're not going to be using the BGP router ID for the peering. Then we're going to be verifying our configuration. Then we're going to be redistributing the LANs connected to each and every router in R1, R2, and R3. And we should make sure that there is no 10.x.x.x prefixes in the BGP table. Use IP-ACL extended in conjunction with a route map to get the task done. Ensure R1, R2, and R3 can reach each other's LAN prefixes from their own LAN prefixes. So to accomplish that, we're going to be initiating the extended ping command in each and every router. We will see that in a minute. And configure OSPF area 0 backbone between R3 and R4. And as you can see over here, we only got two interfaces, which is the G00 and G00 and R virtual lab topology. And then we're going to be redistributing the local area network connected to R4 as type 1 external LSA. Link state advertisement. Then we're going to be verifying our configuration. The most work is going to be with the last task. We're going to be redistributing between BGP and OSPF on R3. So the thing is, over here we got a few things that we need to keep in mind. One of them is that for the BGP, by default, when the BGP routes are redistributed into EIGRP, only external routes are redistributed. But when OSPF routes are redistributed into BGP, only internal routes are redistributed. So we need to have an explicit configuration to redistribute internal BGP routes and external OSPF routes when performing OSPF to BGP redistribution and vice versa. Okay, so the other thing is BGP speaker does not exchange the next hop, so we need to keep that in mind, that R3 should specify the next hop so the internal network on R4 can reach out to the other subnets in the BGP topology. And the last thing is the 150.3.3.0/24, that is the network that is connected to the R3 router, is advertised by BGP. It is redistributed into BGP, but it's not redistributed into OSPF. So we're going to do the same thing. We're going to be using the route map to redistribute the connected route map into OSPF. So let's start with the configuration. So if you enjoy Cisco configurations, the intelligence behind all these technologies, all of this should not be pain. It should be fun and something to always look forward to work with. And I hope that is the case for you guys. So I'm going to start with the R1 enable from the global configuration mode. First, we're going to change the host name to R1. Then we're going to start configuring the interfaces. Interface GI00 that is connected between R1 and R2. The IP address is 10.0.0.1 and the mask is 252 since it's a point-to-point connection, so there is no use to use more IP addresses or slash lower than slash 30 because that's going to be a waste of IP addresses. Then we're going to execute a no shut. Now the other interface is GI03. IP address is 150.1.1.1, 255.255.0, and no shut. This is the local area network connection with the R1, which is the GI03. I always do write memory. You never know. This is a virtual lab. It's I don't know, a few hundred miles away from me, so I cannot physically see it. So I prefer to do a write memory after I'm done with each and every configuration, just to be on the safe side. So now we're going to start with R2 from the global configuration mode. We're going to change the host name to R2. Then we're going to start configuring the interfaces. GI00 that is connected to the R1, the IP address 10.0.0.2, the mask is 252, interface GI01, that is the connection between the R2 and the R3. IP address is 10.0.0.9, and the mask is the same thing, .252. Then the interface GI03, IP address is 10. That is 150.2.2.2, and the mask is 255.0. Interface range GI00 to 3, no shut, 2WR. and end to go back to the privilege mode. Now we're going to type in show IP interface brief to confirm the IP addresses on the interfaces and make sure that we have assigned the correct IP addresses. Now let's ping the point that we have connected between R2 and R1, 10.0, sorry, 0.0.1, and we should be getting a reply. Now let's do the R3, enable global configuration mode, host R3, interface GI00 connected to R4, IP address is 10.0.0.13, and the mask is 252, interface GI01, IP address is 10.0.0.10, 255.252, interface GI0/3, IP address 150.3.3.3, 255.255.255.0. Interface range GI00 to 3, no shut. Do WR to save, and to go back to the privilege mode, show IP interface brief. We got supposedly the correct IP addresses, so now we're gonna ping the point on R2 that is connected to R3, which is 10.0.0.9. And we should be getting a reply. All right, now R4 enable from the global configuration mode, hostname R4, interface GI00, IP address 10.0.0.14, the mask is 255.252, no shut, interface GI/3, IP address 150.4.4.4, the mask is .0 and no shut, then do WR, and to go back to the privilege mode, then show IP interface brief. Alright, let's ping the point on R3 that is connected to R4.13, and we're getting a reply. Alright, so configure EIGRP using autonomous system 254 only for the R1, R2, R3 links. Alright, so let's start with the R1. Router EIGRP 254. Router ID is 1.1.1.1, no auto summary, and the network is 10.0.0.1. The wildcard is quad 0. And R2, we got two interfaces in the EIGRP, so config T, router EIGRP 254, that's autonomous system, no auto summary. Then the router ID is 2.2.2.2. The first network is 10.0.0.2, quad 0 for the wildcard, network 10.0.0.9, quad 0 for the wildcard. Do WR. Now we gotta do the R3 from the global configuration mode. Router EIGRP 254, router ID is 3.3.3.3. No auto summary, and the network that is in the autonomous system is 10.0.0.10. The wildcard is quad 0. Do WR to save, and then show IP EIGRP neighbors. Got 10.0.0.9. On the R2, we should have two neighbors. Do show IP EIGRP neighbors. 10.0.0.10 and 1 for the R1. Do show IP EIGRP neighbors. I hope this is not annoying for you guys, but I literally did close to, I would say, 1,000 laps. So the more I do the laps, the shorter the words that I write. So it just becomes a habit. You know by heart the line of command. You understand the science and the idea behind running that command. So by the time you will start, typing the command as a shortcut, it becomes a habit, as I told you guys. So we're done with the second one, and we confirmed the configuration, and we did not add any other interfaces to the EIGRP. Now we gotta configure BGP and autonomous system 254 as per the figure. So we're gonna start with the R1, so router BGP 254. BGP router ID is 1.1.1.1. Neighbor is 10.0.0.2. Remote AS is what? 254. You gotta remember that we are peering with other routers using their interface ID or their interface IP address, not the router ID. Second one, router BGP 254. BGP router ID is 2.2.2.2. Neighbor is 10.0.0.1. Remote -AS is 254. Then the other neighbor, come on, neighbor 10.0.0.10. Remote AS is 254. Do WR to save. Now the last one is R3. Config T router BGP 254. BGP router ID is 3.3.3.3. And the only neighbor we're going to be adding to the routing table is 10.0.0.9. Remote AS is 254. Do WR. Now let's confirm. Show IP BGP. Summary. Now we got the 0.0.9. But on the R2, do show IP BGP summary. We will find the one on 0. And for the last one, all right, I'm not going to deal with this right now. So I'm going to do it this way and expand it. Do show IP BGP summary. We got the 2. Now, why we don't find the R3 and R1 on each one of these? Because we need to add a reflector on R2. So we're going to do that when we redistribute the connected LAN interfaces. So we're going to start with the R1, and as we said before, we're going to be using the IP access list and the route map to redistribute these internal networks into BGP. So on R1, access list extended 100 permit IP host 150.1.0 to host 255.255.0. Now route map, we're going to name it connected. You got to keep in mind over here, I don't know if it's a reminder or something new or you didn't pay attention to earlier, but it's good to mention it anyway, that remember exactly how you wrote down the name for the route map, because the way you write it down, it should be added to each and every subsequent configuration. Otherwise, it will not take any effect. So route map connected permit. All right, let's remove the caps. Permit 10 match IP address, and we're gonna put the number of the access list. Now route map connected, make sure that you write it exactly the same way you wrote it the first time. Then we're going to be denying 20, exit, router, BGP 254, redistribute, connected, route map, connected. Do WR to save. Now let's do the R2 configuration. Let's do it another way. There are, multiple ways to do the configuration for the access list. So let's do it the conventional, I would say, the CCNA level configuration for the access list. IP access list extended. Now we're gonna give it a name, connected. Then permit IP host 150.2.2.0 to host 255.255.0. Now route map AMP. Route map connected, permit 10. Match IP address. And the name for that access list is connected. Now, route map connected, deny 20, exit. Then router BGP 254 redistribute connected, route map connected, do WR, and we're gonna exit. Global configuration mode, access list, we're gonna give it a number 2000. Permit IP host 150.3.3.0, host 255.255.0. Now route map connected, permit 10, match IP address 2000. Now route map connected, deny 20, exit router BGP 254 redistribute connected, route map connected. Write memory to save the settings. Now let's confirm the configuration. Show IP BGP. We got the 2 and the 3. Now show IP BGP. We got 1, 2, and 3. And this one do show IP BGP. We only got the 1 and 2. Now we need to add a reflector on R2, so R3 and R1 will have each other's entry in their routing table. So from the global configuration mode, router BGP 254, neighbor 10.0.0.1, route reflector client, then neighbor 10.0.0.10, route reflector 2WR, and now let's see if that is reflected over here. JSON changed 21.18.49. Okay, show IP BGP. Now we got an entry for the one network. Let's confirm that we can reach out. Ping 150.1.1 source GI0/3. Now we got a reply. So let's try the other way around. From here, do show IP BGP. We got an entry for the 3.3.0. So ping 150.3.3.3. Source is 150.1.1. Repeat 200. We got it. All right, so the next part is to configure OSPF. So we're gonna start with the R3, WR to save, WR to make sure that we saved everything, enable file memory, and R3. From the global configuration mode, router OSPF 3, router ID is 3.3.3. Network is what? 10.0.0.13. The wildcard is quad 0. The area is 0. Router 4. From the global configuration mode, router OSPF 4, router ID 4.4.4. Then we gotta redistribute over here. We need to redistribute the connected OSPF as type 1 external LSA. So redistribute connected subnets metric type is 1. Okay, so now interface GI00, the connection between R3 and R4, IP OSPF 4 area 0. Now it came up, loading done, loading to full. Do WR, and let's confirm that. Show IP OSPF neighbor. We got 3.3.3. Now show IP OSPF database external 150.4.4.0. What do we got over here? It says external and the metric type is 1. Alright, so now is the last part, redistribute between BGP and OSPF on R3. Nothing on BGP though. BGP should only redistribute external type 5 routes from OSPF. Ensure that the 150.4.4.0/24 subnet is able to reach all other LAN subnets and vice versa. So everything should be done on R3. So exit. Router BGP 254 redistribute OSPF 3 match external 1 and external 2. BGP redistribute internal. Then we need to set or configure the next hop neighbor 10.0.0.9 next hop self. Now we're done with the BGP. Now we gotta do the router OSPF 3 redistribute connected subnets route map what connected. Remember, we gotta redistribute the 150.3.3.0/24 into OSPF. It will not be redistributed by default, so we gotta do that manually, as what we have done earlier by injecting these LAN interfaces and redistributing them into BGP. Now we need to redistribute BGP 254 subnets. Do WR. Now we should see the 150.4.4.0 in the OSPF database of R3. Here we go. Now let's confirm that R1, R2 will find the route or will have an entry for the 150.4.4.4 in their routing table. Show IP BGP. There we go. On R2 as well. Show IP BGP, and we got entry for the BGP. Now let's do the extended ping. Ping 150.1.1.1. Source GI03 repeat 10. We got a reply. Let's do the other router 2.2.2, and the third one is 150.3.3.3. Now let's try from R1. Ping 150.4.4.4 source GI03 repeat 10 size 9100. Jumbo packets. We got a reply. Ping the same thing 150.4.4.4 source GI03, which is the internal network on R2. Then repeat 10. And that's all, folks. I hope that it was useful. If you have any comments, please hit me up. Be good.